Hello and welcome to another video. Today we have an Asus B450-F Gaming on our bench, and this board has seen some better days. You ain't seen nothing. Like, have a look at this one. Do you see how dirty that is? And like what has happened to this? And one more thing is the actual problem that we're going to have. I think all of the parts of the BIOS chip are ripped off. Every single one of them. So this is going to be one hell of a repair. No idea how this happened with this board, but we will have to try to fix that. We will definitely have to do some visual inspection for this board, because I can see, for example, around the TPU chip, there also seems to be something that has happened. And I'm not too sure if we will even be able to save this board or not, but we will certainly try. Let's see. Backside doesn't look as bad, but you can see around that place where there has been work done. There's definitely also some on the back. So first things first, what I'm going to do, I'm going to take some cloth, some of these, and I'm just going to go around the place and clean everything off as best as I can. And let's see to what kind of state we can get this board to. If this is even fixable in the very slightest. So I spent quite some time cleaning this thing, and as you can see, it's still not great. Like around some parts, as you can see here. I really cannot tell what the sticky residue is. Like, is this some kind of flux that someone used that is this bad? Like, I'm really not too sure. Like, look at how it deposits here. It looks like it is some kind of flux. But this is awful. Like getting this off, and yeah, this is the biggest part. So this looks like the 1.8 volts was shorted. Very interesting. Have a look at that. This is the 1.8 volts right here. I can tell that because there's the capacitor. This is then pin 8, and this is pin 1, 1, 2, 3, 4, 5, 6, 7, 8. And yeah, this looks like it actually burned. And as you can see, the trace is lifting, but there's still all of the connections, like the connection to the capacitor, to the filter capacitor, then to that resistor right there as well. And yeah, the ground pad is still there. I think that's the ground pad. Yeah, and then there's some traces ripped off here. So if this would be the only damage that occurred on this board, this wouldn't be too bad, to be perfectly honest. But, oh man, let's bend these a little bit back at least. These don't have to be perfect, I just want them to not be touching. We're just going to do this with some tweezers here. Just bending a little bit into place. That's good enough. So, look at this. Like, what kind of flux is this? Is this like plumber's flux that behaves like this? Because this stuff is awful. It doesn't corrode as far as it seems, but it crystallizes up, which is very annoying to clean. Like, what the heck, man? But I'm thankful that it's not corroding anything. So, there might be something missing here. There might have been a component here at one point. But elsewhere, I don't think that there's any missing components anywhere. At least for the BIOS chip. So, let's see where the... around the CPU socket right here. if we can see any damage. Some more of this crystallized flux, man. But I don't think that there was any more physical damage. Like, surely it is so dirty, but physically it seems fine. Like, it might be that there was only the problem around the BIOS chip. That someone has tried, like, to flash the BIOS by hand, and it all went south from there. So there's some signs of, like, of liquid damage or similar stuff like this, like you can see here. But this isn't too bad. This might also be from a smoker then. Like, this is stuff like nicotine that deposits upon people smoking close to their PCs. That can happen. I've seen that many times so far. Yeah, and here's more of that. Man, this looks so bad. Is this like a piece of wire right here? Oh, it's so hard to grab because it's in between RAM slots. Yeah, there it's just out. So, it does look bad, but the only area that seems to be really have been touched at seems to be the BIOS area. So this is now Ethernet right here. So let's move to the SIO. And the SIO looks fine. That is good. Nothing special here. Then let's look at the TPU chip where I've seen something as well. Like, there's some residue right there on that transistor. But I think there wasn't any work done here. Which is good. Okay, if that Windbond chip might have been touched, that would be bad. If someone had flashed whatever was on there. Let's hope that that didn't happen, because that would be really bad for us if the TPU firmware has been altered. Let's just ignore that for now. Okay, close to the PCH now. And some dirt, but nothing looked to be bad here. Nothing knocked off, nothing played with. Okay, before, let's first go to the backside of the board just to check that as well. So the backside has very few components. There's mostly the filtering caps on the back of the CPU. Then a lot more dirt that I will clean up. Let's see, behind the BIOS chip, the header looks fine, as we can see. Nothing shorted there, nothing damaged, that is good. Then let's see behind the PCH right here. And behind the PCH, nothing damaged, but mostly just filtering caps as well. And there isn't really much more fitted on the backside of this board. So let me clean this up. And then we will go to the front again. So I cleaned this board up a little bit more. And what I've done also, I've cleaned the CPU socket out a little bit. And I've checked for major line shorts. So I forgot to record that. But we don't have any shorts on the 24 pin. No shorts on the 12 pin. So that is good. But one thing I definitely need to do is we need to check the 1.8 volts that is on the BIOS chip in order to see if there's a short there or not. Because we saw that that area was burned. So I'm just going to go onto that capacitor. But we don't seem to appear to have a short. So if I'm on the other side of the capacitor, I should see low resistance, yes. And going on the 1.8 volts, no short. That is good. So the 1.8 volts is definitely not shorted. But I want to see for the passive power consumption for this board to see if anything might be majorly dead on this. So let's see. 100 milliamps. 100 milliamps looks fine. That is the power consumption that I'm fine with. And this should not have a reaction to the power button because, yeah, we don't have a BIOS chip on here. So if we... Oh, this actually reacts to the power button even without a BIOS chip on here. That is very interesting. Okay, so even though we don't have a BIOS chip, it reacts to the power button, but obviously we are stuck on 1.4 amps because there's no code for the board to execute. Let's check if even without the BIOS, our voltage for the CPU is running. Let's see, can I find... Yeah, right there on a capacitor I see 0.94 volts. So VCore is present and the CPU gets hot. That is a very good sign. So our power supplies seem to be fine on this board. And this might actually only be the BIOS that needs to be put back onto here with all of the pins that need to be repaired. But that shouldn't be too big of a problem, to be perfectly honest. One thing we need to find out is what kind of BIOS chip belongs on here. I would guess that it's a 1.8 volt chip. It could be a 3.3 volt chip as well. Like, the only real thing is to either measure what kind of voltage gets to the board. So if you wouldn't have a board view, what you would do, you would measure pin 8, because pin 8 is always the supply. And you would see if there's 1.8 volts or 3.3 volts coming to the chip. And also then you could go to the Asus website and check what kind of BIOS size is given for this exact board. And like that, you could pick a chip that would fit onto here. So let's see if in passive state we can see the voltage that is supposed to be on this. And there we are, 1.7 volts on that capacitor. So this is a 1.8 volts BIOS chip. And now we could go for the Asus website and see what kind of, how big the BIOS file is that is being provided by Asus. And by that, pick out the right chip for that. But I do have a board view, I'm pretty sure, so we can confirm it with that. So let's go to the PC and search for a Strix B450-F Gaming. So let's see, here's our board view, and let's have a look now. As you can see, pin 8 is 1.8 volts, like it's written here. And this chip is a... Does it say what kind of chip it is? I don't think it does. So yeah, there's actually no part number for the chip. It just says device DFN 8P, and that's it. And it basically only tells us about the footprint of it and not the actual chip that is being fitted into here. So we will actually have to see for the BIOS size that is being provided on the Asus website in order to find out what kind of chip needs to be on here. So let's then Google for this board. So right here, we are on the Asus product page for the support. This is the ROG Strix B450-F Gaming. Let's take the latest BIOS. Let's download that. And right now we have the cap file and we need to convert this to a bin file. So what Asus does, they give you a file that you cannot just flash onto the chip itself. You need to unpack this. This is similar to a zip, but it doesn't make it smaller, it makes it bigger. It's called a capsule, where it's hidden within. And we're going to extract that. That is very easy. There's a tool called UNI-T tools. And all we have to do now is we have UNI-T tools open. We drag this into here. We see the AMI capsule. We open this by the left arrow right here. Then we have the UNI-T image. We right click it and extract as is. And that is all we have to do. And now we have the actual file that we need. And if we check the size of it, we can see this is a 16 megabyte chip. So now we know that on the chip that we have, there has to be written 128 megabit in order to be for it a 16 megabyte chip. I've also seen I do have schematic. So very interesting. The schematic tells us that there's a 256 megabyte 265 megabit chip on here. So a 32 megabyte chip. Very, very interesting. So this calls for a Windbond chip, a 1.8 volt chip. Oh, I do not know. So, but the BIOS file is definitely small. This will be very interesting what I will be able to fit on here and flush onto here. That is so interesting. Let me see if I have a video on a B450-F Gaming where I see what kind of BIOS chip is on there. Let me have a look. So I got to be honest, I don't have a definitive answer what kind of chip belongs on here, because the BIOS file size tells me that the smaller kind of chip does fit into here, but the schematic told me that there needs to be a bigger chip on here. So I'm going to try with the 1.8 volt chip, but the smaller size first. Just as an experiment, I want to try that. But first, we will have to prepare this place in order to even get a BIOS chip onto here. And yeah, what we basically have to do is we have to rebuild all of these traces. It should be doable. Like, it isn't the easiest, but it should be doable. So for now, what I want to do first is I want to clean off all of the contacts that I need, where I need to solder a wire onto. So let's see. We need this down here. So this is cleaned. We need this up here. And let's see what else we need. We need this trace right here. Then we will also need to connect maybe to the bottom there, but not too sure. Let's see. Then there's a trace right here that we need to connect to. Then there's a 1.8 volt that we have to connect to here. That is the same that goes to here. Just like that. Does this might need to connect to that resistor as well. We will have to see. We need this trace right here. And we need that small trace right here to the right. I think those are everything. Those are all of them. Let's clean this area up once more. And let's have a good look together if we caught all of the traces where they have to go to. So let's have a good look now. Let's zoom down a little bit in order to get a good view here. So we can see this trace goes up to this one right here and then goes to this part, but I don't think it goes anywhere from there. Then this one goes here, this one goes there. This one I didn't clean. There's a via right here that we need to connect to. So this is our connection point for this here. So let me clean that up once more so we can see a little bit. So now we can see that as well. So we have the exposed part right there. And then let's continue. So for the 1.8 volt pad, we can see that this one went down here as well. And also went up to here to the capacitor. Then this pad right here goes to that trace. And it probably is there. I think yeah, pretty surely it goes to this capacitor as well. Add to this resistor right here. Right there is a trace, pretty surely, that also connected it to there. Will be able to see that by the board view as well, but pretty surely that this trace also connected to the resistor. Then we see, so these two need to be connected, and then we can see the next one. This one connects up to there, which is another trace right here. And this right trace connects to here. So yeah, this should be everything. We will need a very small tip for that probably. Let's see, is this tip too big? This tip might, no, let's change it out for the smaller tip. That will be easier to use. So this is the tip I will be using. This is small enough where it's easier to work with. So let's or rotate the board so I have a little bit better space to work on. Let's start from this angle, from this corner right here. So, one of the most important things in order to get good jumper wires down is to have a good amount of solder where you actually want to have the wire to stick. So that is one of the biggest problems what I see for people that try to repair such places. So let me show you what I mean. It is very important on these places right here to have a good amount of solder. Only then your wire will stick well to them. So with my flux, it gets very gooey, so it's very reflective, but I hope you can still see enough. Let's also tin this up so we can go to there. And then the 1.8 volts, we want some solder right here that we can solder to that. And then we go over and let's see, let's put some flux down again to tin up the other places. So like here and all of these traces right here and this place. So let's see, the via right here. We want to get a good amount of solder onto them. Then these two traces right here. And this is a problem. I thought so. There's the ground plane completely exposed. And the ground plane makes it problematic to solder to this point right there. Because that's the problem with the small tip that I have here, that it cannot really deal with ground planes like this. So in order to wick this off, I will have to change out my soldering tip. So let's get rid of that blob of solder in the middle. As you can see, the bigger soldering iron can handle that easily. So just like that, the pad is clean. Let's now clean this up once more, and then we can already start with our jumper wires. So we're going to start with the hardest one. So with the ones that are in confined spaces. So I like to use 0.02 millimeter soldering wire. I like to use this one from Mechanic. As far as I know, this is not insulated one, but we don't need insulated one here. So let's see then. So first of all, some flux again here. And right now, you will need your best pair of tweezers in order to grab this kind of wire, because it's really thin, like really, really thin. So right here, I have still the big tip on here. Let's see. Even if you don't have the small one, I should still be able to connect this onto here. Okay, this is a classical case of not having enough solder that sticks to the wire and to the pad. So let's switch to the small one again. Let's put some more solder onto the trace here. So, your best friend in this situation, always a good amount of flux, having good amount of solder on there. Let's try this again. Get this wire to stick down here. Like that. And now we can see that there's an actual connection right there. There's a part of the solder that actually has accumulated there and now is stuck to it. And what we do now, let's form a little trace here. I know that there's like pad strips that you can also buy that are basically a complete trace, but I like to do this as well, where we just form this a little bit, bend it up into the right space that we need it to be. Kind of like that. Let's cut this, because we don't need it to be as long as it is. So about here we can cut it. Kind of like that. Got a little bit more of the board there. But this should be fine. So we will be fixing this down with solder mask or with UV gel, but not now. We're first going to continue with the next ones, and then we're going to be putting them down all together. But yeah, this is the first pad basically rebuilt here. Let's continue now with this one. So the wire is attached now, but I don't like the kind of connection that is on here, because I feel like there's not enough, there wasn't enough flux, and it's basically like a cold solder joint. So let's add some more flux. Let's try to make this clean. Why am I even bothering with that? Why am I not even just connecting to there? That is such a dumb mistake from me. Like, there's just giant solder pad that I'm not using. Like, some of you must have been screaming at their screen. Like, why am I doing it so difficult on myself? If there's that ginormous pad right there, just sitting there waited to be connected to. Man. So, next pad is ready. You saw me do it now twice. I think the rest I'm going to do with a quick montage, so I'm not going to do any more commentary, but I will be doing all of them on camera, and we're going to be fast forwarding through them. So now you can see all of the pads are connected. Everything is there like it should be. And today I decided to use UV glue instead of UV mask. Probably not quite the right application for this, but it seems to stick very well and glue down everything very well. Like, I've not used it before myself, but I got to say it works pretty decently. Like, to get it this far, this took about 45 minutes, I think, for me. Not the fastest in doing that, but it is okay, I think. So we got all of the traces repaired. This one going there, from there going there, from there going there to there. Then the 1.8 volt here, going to there. Then this trace going the way to here. This trace coming from there. This one coming from here. And this one, which isn't glued down too well, as you can see. Let's see, while cleaning this, got a little bit Kinda like that. Okay, and now comes the point for putting a chip onto here and actually soldering it down. So, like I said before, I'm not too sure what kind of chip belongs on here, but we will try something out. We will try the smaller capacity chip and see if that will work for us here. So there's the wind bond IC. And instead of taking the one that is soldered via SMD, we are going to take this one. This is also an SMD chip, but it's not a QFN package or a WSON. This is a SOP8 package, I think they're called. And we're going to try to put this guy onto here and solder it like that. My tweezers are so sticky, man. So this will be interesting. I can already see that some of the pads aren't as aligned as I hoped for. But I think we're just going to use a small soldering tip now. And let's start this. And let's see if we can solder this down. So I think I got everything connected now. It's not looking the prettiest yet. I will clean that up. But in my insane intelligence, I forgot to flash the chip before. But that will give us the opportunity to use this pin header that is right here, bend it into place again like it should be, and use it to flash this BIOS chip. And with that, we will confirm that all of the connections to the BIOS chip are fine. If this pin header also can connect to the BIOS chip. So I will clean this up a little bit more, and then we will try to use the adapter that I've made, the adapter cables, to connect to these pin headers. And from those pin headers, we're then going to try to flash the bin file onto this BIOS chip, and we will see from then. So let's see if our chip can get recognized. So with 1.8 volt chips, 1.8 volt for the chip, it's being recognized. Let's read it out. I think there might be some BIOS on here. Not sure if this is a used chip out of my stash or not. But yeah, we will definitely delete whatever is on here because this would not be the fitting BIOS for this board. So there's actually content on here, and I think this is an MSI BIOS that is on here. So let's open up the file that we need for the B450, then we need the Strix F Gaming, and then this image. And the buffer size definitely says that this does fit. If the buffer size in the bottom left would be too big or too small or something mismatched, this would be in red. But it is in normal gray, and it looks fine. So let's just flash this BIOS then onto here. So the BIOS is flashed. Let's see if any of this worked now. So the time has come to test out this botch job, if all was for nothing. So let's see. Passive power consumption, 110 milliamps. Let's hit the power button. We saw 1.5 amps, and we want this to be a higher number now. Let's hit it. 2 amps, that is so good to see. And we can see there's a CPU LED. Will this change? It seems to be changing. DRAM LED. We see jumping power consumption. That is very good. Let's see. Will we get a capture? I just saw a green light, which is the boot LED. It went off. Let's see. Can we get a boot screen out of here? Is it on already and I'm just not getting a capture? That might be the thing. It might also be flushing some firmware itself right now. And one more thing is, oh, there it is. There goes the fan. And the board is on. We can see it by the caps lock that the board is on. Let's hit this button. So not getting a capture right now. Probably something with my connection. So let's turn this off. Let's put a graphics card into here to get an actual display capture out of here. So, and once more, this time with the GPU in there. Oh, so good. So good to know that all of the work that we've just done isn't for nothing. And that that was actually all the underlying problem with this board. Because who knows, with that kind of damage, anything could have happened here. So I guess someone tried to flush this BIOS, tried to take a chip off. And all that they managed to do is just to rip off every single trace. Okay, my capture isn't working. Why is my capture not working? So, I have a big problem with my capture card, so this will suffice. This is a portable monitor that I built. And as you can see, this is actually alive. So, the board is in fully working order now. I cannot believe that, but yeah, the BIOS chip was all that we needed here. And now it's working. I got the capture through the GPU. And yeah, this board honestly needs a good clean in a bath or something like that, because holy moly, it's still sticky all over the place. Like, it's really bad. Like, this thing should be cleaned and scrubbed and maybe even trashed, to be perfectly honest. But yeah, it is working now. I'm going to fix the BIOS chip with that UV gel more in place, because I flashed the latest BIOS onto there. That means that this board never will need another BIOS flash again. For like there's no reason to flash the BIOS again on this board. So yeah, it should stay like that. So I'm going to be fixing down that BIOS chip even more, so that won't move anymore, and all of these connections will be nice and secure on there. And yeah. I don't really know why the schematic called for that size of a chip. Like, the schematic, as we saw, called for a 256 megabit chip instead of a 128 one. But the BIOS file that we got from the Asus website clearly stated that this has a 16 megabyte chip, and with 128 megabit. And that's also what we put on here, and that is what worked. So yeah, once again, a mystery with the BIOS, why ever that is being put that way. But the board is working, that is the most important thing. And I hope you enjoyed the video. I hope you learned something, even though it was mostly just soldering in this case and not too much diagnostics. So all of my tools, as always, are linked in the video description. Thank you very much for watching. This was Mainboard Medic. Thank you very much, and goodbye.